we're going to make a decision tree in UML, or I'm going to try to do it. Why would you do this? I don't know. I can't justify that. It's probably a bad idea. What is a decision tree? Watch this video. This is the video that I watched. It's 9 minutes, 52 seconds. I watched this video, and then I knew science. And here's the code that goes along with it. So this is the Josh Gordon is the same guy. This guy is Josh Gordon. There he is. So here is his implementation of a decision tree in Python. So he explains in that video how it works. And here we go. It's 400 lines of Python, and it's got plenty of comments and stuff. So you can build machine learning stuff from scratch, right? That's what he's showing you. And the decision tree is very cool. So I am already familiar with this code because I actually I kind of like translated this code into JavaScript. So I kind of re-implemented this in JavaScript, and it's not exactly a one-to-one match, but more or less my code's a one-to-one match to his code. So I'm familiar with this code, but I haven't looked at it for several months. That was a few months ago when I did that. Also, I'm not good at UML, and I am not good at statistics. So this is this is a learning adventure that if you choose to watch, you're coming on with me. It's just an adventure. We don't know where this is going. But, warning, this could turn very boring and tedious. I don't know. I mean, we're talking about UML here and statistics. So this could get boring and tedious, especially as I try to figure out how will I represent code. Like is this. We're going to calculate the Gini impurity. Okay, Gini is the guy's name, right? Oh, and here we go. So we actually have a whole Wikipedia article here. So what I'm going to do is I'm going to go through this guy's code here and translate it into UML. That's the goal, right? And whatever other UML, we're going to need a bunch of stuff and maybe some textual description as well. I'm not sure. But in any case, how do I take like an algorithm like this and translate it into UML? I don't really know. That's what we're here to find out. I'm going to be really good at UML if I keep doing this, but that could be a bad goal to have in the first place. So there's no guarantees here. That's the point I'm trying to make, and now we're going to move on and just try to get started. Where do we even start? Generally, in UML, you start with a use case, right? So what is the use case for a decision tree? The user wants to give the decision tree an instance of something, or actually, so we would have actually like a feature set or something. So these are features. So the user wants to give the decision tree a feature or like an example and get back a classification. So that's cool. We can start with that. So I already have a use case diagram set up here. So we're going to have an actor. I'm using Plant UML. I don't have all of this crazy thing memorized, but we can always come in here, and the problem is there's different ways to do things, and I'm going to try not to look at any of my old code because some of it is like for work and things like that. That's proprietary. But anyway, we're just going to do it to our best of our ability. So don't worry if you don't know about Plant UML. That's the point of this, is not Plant UML, but the actual UML diagrams. So we're going to have an actor called user, and we're going to have a participant who will be called the decision tree. Okay, and so basically the user is going to say to the, wait, how does this look? How do they do it? Okay. I don't really know what this should look like exactly. Let's also you can look here. So like this, yeah. So this is kind of the one we want, like the business use case, I guess, or the basically the user says, all right, let's make the decision tree a bigger thing. So I'm doing this wrong. Participant, that's something I would want maybe if I was doing a sequence diagram. It's okay. I'm figuring it out. So I'm going to say we're going to have a package called decision tree. I was actually thinking of this like as a sequence diagram, which is not. We can do that next. It's a very, if we just keep this very simple one, was whatever. And in this package, how does this look now? Oh man, why do I suck at this? Okay. Show me one with the packages. What is it? All right. Okay, so I just put a use case inside the package. We're going to have a use case of get prediction. All right, we're going to say get classification. You could say classification or prediction, I guess. It's just kind of maybe depends on the context of what you're using the tree for, but it is a classification tree. Anyway, that was fun. So we have not made it a lot of progress, but we got some UML here. Decision tree, that's a little big. Just hold up here. Man, org mode, adder, image. What is it? Yeah, adder HTML like this. Let's like this right here. Perfect. It was right there on the Google homepage. Or the DuckDuckGo homepage, I should say. Still too big? What? Did it not work? I mean, the goal here is not org mode, but we gotta sort out. This has to look good too. This is the page I want. Image attributes. This is what I'm talking about. Adder HTML with blah, blah, blah. How is that not what I have here? It is. Oh, you know what? Okay, that is a link. Is this really what we should be spending our time on? No. But here we go. So it should be like this. Style. Yeah. Screw this. This is like so old. Like you don't use a width attribute. You have a style attribute. It's going to have a width of 50%. Okay, now we should be back on track. Oh my lord. Okay. So this is the yak shaving. When you just spend your time doing stuff that you really never meant to be doing, but you just, it happens. So that's what we're talking about here. This is ugly. And of course, we could just update this a little bit. And we're going to say basically that the user uses get classification. And that's that. Okay. So we're getting a little bit, but this is the basic of, this is what a decision tree does. So this is like a hello world. Like when I start building a program, I generally start with like some really simple lines of code just to get the thing running, and then you build on it. Well, this is the equivalent of that in UML. So, and also I don't know what I'm doing, so I'm just doing whatever I can just to get it started. And yeah, we could have a sequence diagram as well. If we have a sequence diagram, so I think the use case and the sequence diagrams can both grow, because we can basically say, hey, well, how does a decision tree get classification? And then we can have this get classification start to use all of the subcomponents of the decision tree, and this eventually would turn into like our class diagram. And right, so when we're doing UML, it's like object oriented, but that's one way of representing it. It's like I'm pretty sure I could take a software specification that's like an object-oriented UML, and I could write it like in like scheme, in like a like functional style or whatever, or like in Python in just like with no objects, but with a straightforward procedural style. So we don't get hung up on the fact that here in UML we represented as objects oriented. That's just because UML is like mostly an object oriented language. And now if we went out of our way, we could even avoid using classes and objects in UML, but we're not going to do that. We're going to be like okay with classes and objects, and know that just because in UML you implemented object oriented, that doesn't mean that in your language of choice has to be object oriented. You can implement it in any kind of style you want. The point is just to communicate the ideas and like the structure. Okay. Well, I'll do some examples of that probably one day in the future as well. So here's how the use case can kind of like break out into the things. But let's just create a sequence diagram as well, just so we have like kind of two different things here that we can break out, because you sort of need them both. In UML, we're going to need multiple diagrams, like many diagrams. We'll need many diagrams to actually get around to explaining everything. So we are going to have that. Now, okay, so we're not making a lot of progress here. We're making slight progress, but that's okay. I'm going to take slight progress. Don't worry, I only have an hour to work on this right now, so yeah, I don't know why you shouldn't worry because of that, but like we won't be here for like 6 hours doing this. Maybe, but not today. And let's go ahead. Yeah. So basically, the user says to the decision tree, here's an example. And we'll just say kind of like, in other words, that's a feature. And then the decision tree is going to have to do some stuff, but eventually it's going to say back to the user, here is my predicted classification. Yeah. And that's that. And we can add this into our document here. We're going to call this sequence. That's good to go. We can build this, and we can build these, and we can come take a look, see how much progress did we make. Okay, so these are all way too big. I don't want to make like my default width 50%, because when we get to bigger diagrams, we're going to want them to be full sized. But like these that only have a couple of things, it's like, why are you so big? Okay. So here we see that the user gets a classification. Here we see more of the sequence. The user says, here's an example, and then the decision tree responds with, here's my classification. And while we're at it, let's get rid of that footer thing. How do we get rid of that footer thing? Well, we'll get to that. We don't really need to worry about that right now. But right, remove the hide foot box. Yeah. Let's just go ahead and do that as well. Let's see if we can make a little more progress with this. Okay. So now we can start looking at the code, I guess, and we can say, all right, this is this is what happens. This is like the main thing that happens. Now, what does the decision tree do from here? We can basically forget about the user at this point, And now we're going to like get into the decision tree and say, what does it do? So let us, the first thing I guess we can do is kind of read through the flow of like the calls in the code. So what we're doing here is for row and testing data, take row -1, that'd be like Apple. Okay, first we're building a tree from the training data. That is, okay, so that's a key thing. So we have these things, build tree. But yeah, so let's, what we can do now, we can start taking all the functionality. Oh, this is already has some objects in it. So that's cool. But it has some objects, but it also has some not objects. So I don't really know why. I guess I understand why we have these leaf and decision node objects is because we actually have many of these things. We have many leafs and decision nodes. But then we just have a bunch of just top level functions. So let's see. The first thing we're going to do is build tree. And I wonder what print tree. Does that actually print out the whole tree? The world's most elegant tree printing function. Yeah, I bet. I'm with him on this. I've done the same thing, trying to print out the decision tree. And, there's actually all kinds of papers about like how to render trees. But anyway, let's start documenting some of the functionality we're going to need here. I'm just going to do this. I feel like this isn't like I feel like it's cheating or something, but yeah, we're just going to we're using UML as a tool to help us with our code reading. So if we're cheating, we're cheating. So whatever. Okay. So let's go back to creating use cases. Okay. Let's put it in the document. But now we're not worried about the user anymore. So we're going to do it like this. We're going to have like a participant called decision tree. And we're just going to have a package called functionality. I mean, that's it. Like we don't really know at this point how all this functionality should be organized into like a nice system. We'll worry about that as we get further. But we're basically going to say for now, just kind of like sketch out like, all right, well, what are the things that we want to do? Well, get classification is definitely one of them. Why does it indent like that? Is that the indent they like? Okay. Now we have build tree. Okay. Classify. We'll just call it classify. Classify. Build tree. I'm going to do it my way. I'm going to not, so use like English. Printing the tree we don't care about. Printing the leaves we don't care about. And find best split. And that, so now this is where we're going to start figuring out what the hell's going on. What is going on here? And we have the other one was we had the find best split, and we had info gain. And we have the Gini impurity. Okay, we're getting something here. Partition's a data set. I love this is like well commented code because it's like supposed to be educational, so it's got little demos and stuff in it. So that makes it really easy to read through and know where you're at. But for each row in the data set, check if it matches. So this is what I mean by cheating. So if I just say partition, But at this point, like, I don't even know like where partition is called from. So let's let's at least read the code a little bit and understand where partition is being called. It is not being called in InfoGain. Even though here, okay, so it's just telling us true and false. Okay, so it says partition, but we're going to like basically say true or false rows. Get true and false rows. See, it's important that we don't just copy, like, you know, if we just copy this thing called partition, like, what have we really done? It doesn't, you know, we need to understand what's going on. And of course, as we get more and more detailed, we are going to understand what's going on as we actually get to implementing lines of code in UML, which I don't understand how we're going to do that. But so the question is use partition a data set. So that's kind of getting beyond like use cases, you know what I mean? Like, I sort of feel like see what we're going to do here is we're going to kind of separate. I wonder if I put a line here, if that'll separate things. We're going to, we've kind of like extracted some of these like things that we know we're going to do from the code. But if we're sticking with like a use case diagram, what we're really saying is that a decision tree can classify, and the decision tree can build a tree. Might as well put build tree first, since that kind of is first. And that's really all it does, you know. This is all that it does. It builds a tree and it classifies. These other things, these are just implementation details of these top level use cases. So let's see if line 4, sure. Let's see if we're making any progress here. Okay, line 6, sure. What's wrong with my package? If we look at use case 1, is it the same? It is the same. Okay. So I'm debugging by just removing code. And seeing what happens. And now maybe participant is a problem. I don't know. There's no image in Scratch, that's fine. But we did get used to done. Okay, so anyway, let's take a look really quick at the use case diagrams. That is part of what we're learning here. So we have actor. We'll just let it be an actor. Screw it. I was trying to do something. I guess it's either got to be an actor or a use case. This could be... I should not have named that with a .puml extension. What? It's supposed to open dired. Okay, that's better. So let's go ahead and remove it. Okay. Now we're good. So I had a problem trying to have a participant in there where it didn't belong. It was really an actor. Okay, so now this is cool. So actually, let's get rid of that 50% guy. We don't need him anymore. Not for this one. And this is what we got. The decision tree can classify or build. And actually, so we want something like this. First of all, let's just say, is it left to right direction? Is that the direction we want? And right here, let's see if we can insert a horizontal line to just separate these things. Help us think about what's going on here. Okay, error in line 11. Okay, gotcha. They didn't like the horizontal line. That's fine. So the decision tree. Yeah. Why does it do this to me? Okay, here we go. So so this is basically wrong. This is not exactly right. So build tree and classify, now that we're looking at these are things that the decision tree can do, you know. So these things we know can go in their own box up top here. They're, you know, build tree and classify belong in a package together. But they should probably be in the package called decision tree, you know. But really, so it's like kind of like the, you know, I don't really know exactly like the correct way to do this, right? But just, you know, we're just trying to think. So let's do this. Let's take these, put them here, and let's change this to implementation. And again, it's just a placeholder to help us start making progress. This is very much similar to how I program in real life. I would just like get some stuff going and then build on it. So for instance, building the tree, I'm pretty sure all of these things are related to building the tree. And since what we're really doing is reading the code and translating it, we can actually find out very easily by reading the code. Oh, you know, I should have made all this larger. I'm so sorry. Oh, no. Okay. This should all be larger. This is large enough. I know that. And Emacs should be larger, but you know, the Emacs portion of this is actually not really important, so we'll leave it how it is. Okay. So here we go. The first thing we do is go to build tree. So can we like just click through to it, or right? Okay, builds the tree. So this is a recursive thing, and this is great because I'm not sure. Yeah, like I don't know how we're going to represent this in UML, right? But I already know this. We're only going to worry about building the tree for now. We can also look at the implementation of classifying, but we're really just going to make it our goal to do an implementation of building the tree. Because that's probably the hard part anyway, and you need it first. And it's always good to make our goal a little bit smaller if possible. So the reason I said it's like I'm cheating is because like the really good way to do this, and now that I'm doing this, like I'll consider this for the future, or this is kind of just part of the process. So I'm reading this code here. I've implemented this code in JavaScript before. Now I'm implementing this code in UML. What the real mastery, like I'm not a master of decision trees or machine learning or statistics or anything like that, but if I was, I would be able to demonstrate the real mastery by just starting from scratch and showing you how to build the whole thing in UML. So that's cool and that's a good idea. But my idea was to read code and use UML as a code reading tool. So that's what we're going to do for now. But I think in the future, That'll be like the final test. Be like, oh yeah, do you really understand it? Because there's some things that I know cold that I could show you, hey, this is how you do it. And I could just write it out in Python with no references or anything. So maybe we'll get there with decision trees. Maybe I'll get so good at it that I could just like tell you from memory or just from my own intuitive understanding how to do everything. But for now, we're going to read this code, and it's well documented. Base case. I don't need to know how recursion works, but thank you. Typo, but that's all right. I have typos. So you try to partition the data set of each of the unique attributes, calculate the information gain, and return the question that produces the highest gain. So we could actually, I guess, probably make an activity diagram for this as a reference of like how this is going to go. I don't even know how to do that. So I don't even know what an activity diagram should look like, to be honest. But I like this website here. I don't know if it's the greatest, but uml-diagrams.org. Look, I've looked at a lot of UML sites, and this has been the one that's been like the least painful. None of them are like awesome. UML is difficult to make something awesome, but maybe I'll be able to help with that. This isn't really helping me a whole lot with an activity diagram. Nice. The problem is there's so many like little like all these little details that and I don't even really care about all the little details, So whatever. All right, so here we go. We'll just go off of plant UML for now. So what is it? Yeah, so I don't like this thing without I like to name all of my stuff. Wow, look at this. Okay. I guess this is definitely the diagram we're going to need, I guess, to start like showing algorithms, right? Okay. But still, I don't like having just the bare name. I really like having an identifier if possible. So that's what I'm just scanning this to look for an example of using an identifier. Like for here, so something went wrong and we go back to the start. So, oh, this is just a repeat while. So this just is built into the language that it repeats from wherever I started to repeat. Got it. That'll be how we do our recursion. If we can see them showing us notes, swim lanes, right? I don't know. What is this? Wow, so you can set the different rendering for the activity. That's cool. So anyway, they're just showing it using just this colon in the front, and that's it. So we'll just follow the examples that they have here or whatever, and let's do it. Okay. So we're gonna have activity 1. All right, we got a start and a stop. Okay. Activity 1 .svg is what it's going to be called once we render it. And we're going to add some notes here as well that basically, like as we read through this, we have the, it's great that we have the diagrams, but we're certainly going to need some notes to annotate it. And of course, with Plant UML, we can add notes to the diagram, but I also mean like we're going to have some text on the page here, right? And in fact, everything that I've been saying, I could have been typing up a lot of it, but we'll just come back and do that because it's not really exciting to watch me type. I mean, I know none of this is exciting, but whatever. Okay. So we can render this. We can render this. And then we refresh our page. We have this. This is our activity diagram at the moment. So that's really cool. What does our code do? So we're just reading this code, and we're going to say that it's gonna get the gain in the question from find best split. So yeah, I actually don't even know what that means. How does that even look in here? You know, this actually like sort of concept of like a variable, yeah, counter. But is there a concept of like a function call or whatever? Like I don't know. I guess we had to read the code a little bit more, see what we can do with this. All right, so we're gonna get a gain and a question for all of the rows. So, okay, so we have a single gain and a single question. So find best split is going to have many gains and questions, right? This is going to go through all the rows, but at the end of it, it's going to return the best gain and the best question. So that's cool. So we're going to have a gain and a question. These are, you know, some variables that we have. Okay. So if gain is 0, then we're going to return a leaf. What does that mean? Well, this is like recursive, right? No. It says it's recursive. Yeah, we're going to call build tree again and again, right? So this is our base case that gain is 0, meaning that we've learned nothing. So let's return a leaf. For all of the rows. I think I jumped into something that was, all right, hold up. Hold up. Let us start at a lower level, possibly. I don't want to give up on this higher level. I mean, it's only a couple of lines of code. It's like literally just 1, 2, 3, 4, 5, 6. It's only 7 lines of code. All right. So I think I'd actually have more luck if I went down to the lowest level of the code and started building up. But yeah, let's try this. Okay. I really don't like. I could represent this as a sequence diagram, kind of. What about like a state diagram? It would help, I guess, if I. Aha. Yes, this needs a state diagram, I think, not an activity diagram. Right? What's an activity diagram for? This page doesn't explain. This page doesn't explain. So let's just go here, see what they say the activity diagram's for. It shows the flow of control. Or object flow with emphasis. So that's cool, but I think that what we really want is a state diagram. This makes more sense, maybe. Let's get some more understanding of how this works. Actually, let's look up the state diagram on this page as well. Is it just under state machines? Is that? You're right. Same thing. Okay. Aha. Got it. Okay. What are we going to do? We're certainly going to have a thing called like build more of the tree. You know? Like that's our first state. Let's just see if we can make a state called build the tree. We'll refine this as we go. Here's a simple state. So we're just going to have a state. I want a sort of a better way of writing this. Can state 1 point to itself? No, that probably doesn't really help us at this point. Who cares? Okay, so this is what we got. This is what we got. This is so stupid, but whatever. Build more of the tree. Okay, all this is going to get reworded and clarified. We gotta, we have to just take little steps and figure out what we're doing. They didn't like that. They didn't. What's the problem? Oh, because it's right. Okay. What if I did this? They're not like really clear about the syntax of plant UML. But will this work? You just have to look at plant. You have to like learn just from the examples. There's not like a, I mean, maybe there is, but I haven't like found like a really clear like what the syntax is. Okay. Build more of the tree. Perfect. And there's an actor on there as well. We don't even know why he's there, but they just decided we need an actor. That's fine. Let us go create a starting guy, right? So we say starting guy to build. Oh. How's this look compared to our, I don't know. I don't know how that looks, but let's see. Okay, errors. Line 7 has an error. Okay. What if we just did like that? Man, what's the problem? Okay. We got something here. We start and we build. And they know that this is a state thing. So that's cool. So what if we did like this? Build more of the tree as build. We want it to be as descriptive as possible. We don't want to just say build because who can just read it saying build and know what that means? You know what I mean? We want to give as much context in our names as possible. Oh man, it didn't let me do it. Okay, what if I do this? And if you've read of the tree, if you read Code Complete, I think that's where I've got this idea, but it's become a really big part of my coding. It's like if you can't come up with good names, then you're screwed. Like your names should all, like your names of variables and functions and objects and things like that, they should all very much match up with what you're doing. Okay, so build more of the tree. That's fine. We can do it like that. It's not exactly how I want to do it, but it works. Your names you should be able to read your code, and it should just almost read like English, no matter what language you're in, I think. I mean, not if it's in J, but, you should not have cryptic names. You should have names that tell the reader what's going on. All right, so build more of the tree. All right, well, we have gain and question. What is this state machine? Okay, so if this first thing that we see here basically is that if the gain is 0, then we're going to return a leaf. So we're going to stop the recursion. So what's that going to look like in our state diagram? How do we say like if? So the if statement is like, you know, kind of more of like the activity diagram thing, right? But no, because this also is talking about state, which means that like choice, where is this choice? State C, choice. And then here we have our branches. All right, let's, oh, so I could have done it like this. That's what I wanted to do. Why won't they tell me these things? State, build more of the tree. As build. I don't know, like, why do I have to learn this in such a difficult way? But that's how plant UML is. It's all right. Okay. So we're going to have another state, which is called no more info gain. And we'll just call that yeah, we're going to say no more info gain, true, false, basically. There's different ways that we could write this. We could have a choice, and then we could have one branch that says info gain 0, and the other, you know, we could do that. We could have a choice, blah, 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 but, well, we might need to do that depending on how this renders. Actually, let's look at the UML state machines here and see what they have for choices. Choice, okay. Yeah, they like to take the choice and name the outgoing transition based on the condition. So I don't think if I label my thing choice, it's actually going to show me like the whole name, but let's just see that and then we'll change it if we have to. And let's just say build goes to no info, and let's just see what it looks like before we go too far in the wrong direction. If it just gives us a little diamond, then that's not going to be, oh, no more info gain. Oh, because I didn't give it the choice thing. I'm not sure I'm doing this right. I am learning UML and plant UML all at the same time, so yeah, so they don't give you the thing. So we're actually just going to call this state no info, or info state no info, right? So that's fine. We have to do it the way that UML wants us to do it. You know, you can't really fight with the language. It's not a good idea. So the way you do this is you can label these branches. So basically, from no info, we can go to the state return leaf. So I'll create, you know, state return leaf of the tree. As leaf. So no can go to leaf, and that's going to happen. And then I can label it. Looks like, oh, you just put it in square brackets, and that's just what they, oh, so ugly. Okay. No more info gain. And no info. Well, let's just try that. That's because that's the first case, and then we'll deal with all the code that goes into the next case. Okay. All right, so build more of the tree, no more info gain, then you can return a leaf of the tree. Very cool, but what do we do if there is then we get our true rows and our false rows. All right, so this now it's like it blends into it's like it blends into where we do need the activity diagram as well, but I think we got it. So It's basically just saying build. All right, so this diagram ends up. I mean, I think it's really useful to have, but at the same time, it doesn't tell us anything. Like it does tell us something, but it ends up being so simple. I guess it's good. I'm just babbling. I guess it's good that it's simple. Okay. So, and we're going to say build true and false features. Is that how they call them? Rows. Yeah. Branches. So these don't need to be like that. Just say build true and false branches. So it's like this doesn't capture everything, but it actually sort of captures what we're doing. You just need more diagrams to supplement it. I kind of want it to look nicer. Not really sure. Let's see what we can do. You can make it look nicer sometimes with different ways of rendering the arrows. You sort of like tell it how you want the arrows to lay out. Yeah, this is okay. This is all right. So I actually want to get rid of the start guy, if possible. Now, like the layout of this is not super important, right? But I wish it would just kind of mirror, like flip this, but if this is going to be good enough. Okay. So build more of the tree. Right. Maybe we should have had the start thing in here. Let's see. We're not going to spend all day worrying about how this renders. Like that can be cleaned up later on my own time. But I don't like how start is at the bottom. You know, like really, guys? I mean, it doesn't know. All right, this is fine. Whatever. So you start, you build more of the tree, and then you go to this decision, which is basically, is there info gain? Like, can I label that? Let me look up labeling. This would make it a little bit better. Make this thing useful. Note on link, note. Sure, let's look at some notes. I want to see yeah, okay, let's do this. Okay, let's do it. Let's do it. So we want to put a note right here. We can experiment with where that note's going to go. It doesn't, it's going to be fine. We could say for now, let's say note left of no info. There's like different ways of doing notes, and it's all the examples are just spread out through the different diagram examples. I have not yet found just like I want to look because I keep saying like I don't see it, but I have not found just like a concise reference. Okay. Okay, we're gonna do it like that. Check. What's this function that we're going to need? This is the find best split. And if we go back to kind of like our, here, find best split. And it's going to give us question. So now we're using notes to really supplement, like, I guess. So we'd kind of want to like use diagrams to describe this in more and more detail so that we actually capture everything. So for here, we're just going to use a note. But what we'd really like to do is be able to get rid of these notes. Hey, where's my note? Not really sure why it's not working. I want to see my note. Then I have to go. I'm out of time. Okay. So here's the note. We put it to the left of, and at least that kind of forced our starting point to the left a little bit too. So that's cool. But it's kind of like a big note. Let's like put a new line in here. Something like that. Okay, so now it's a little more readable. Actually, this is a great looking diagram. So this needs more diagrams to supplement it, and this is just explaining what this condition is. So actually this note's not that bad. But we'd want to see, I want to see next, can I actually represent this same thing with an activity diagram? I'm not really sure. But I'm out of time for right now, so that'll have to wait until next time. So yeah, this has been an hour of messing around with UML. Pretty cool. We've we've made 4 diagrams, but we made some progress from just the user gets a classification. We actually made progress to like, okay, and here's a recursive function that builds a tree. There's some details lacking about how it's implemented. But it does show us that we're going to create this recursive function that builds a tree. And I don't think that what I'm doing here is exactly the results you would get if you were just designing in UML or designing I am really like copying the sort of like the literal implementation from this code. So I think that's fine. I think that's a valid use of UML. It's like, I'm like reading the code and I'm using the UML to like verify that I understand what I'm reading. Now for this case here, it's like, I could do this pretty fast, just read it, and not need to write the UML, but I think writing the UML is cool, sort of. And so this use case of it is valid, but we'll see the difference when it's like, okay, so now I really know cold how to create a decision tree. We'll see what the UML looks like when I actually do it, from scratch. And then we may have kind of a different process. So this is the reverse engineering code reading process. There's going to be a different process when it's actually like a implementation from scratch. All right, that's it. I got to go get my hair cut.